Android Studio Implementation Introduction. Android Studio is the official IDE used to build Android applications. Android Studio helps developers create Android projects, write Kotlin or Java code, build mobile UI, run apps on emulator, run apps on real devices, debug applications, test Android apps, manage Gradle builds, generate APK AAB files, publish apps to Google Play. A common learning topic is: how can beginners implement Android apps using Android Studio step by step? This guide explains Android Studio basics, installation, project creation, Kotlin setup, Java setup, Jetpack Compose, XML layouts, activities, app structure, Gradle, emulator, API integration, debugging, testing, deployment, best practices, interview questions. Android Studio is Google's official IDE for Android development. And the Android emulator lets developers test apps across different devices and API levels without needing a physical device. Simple definition. Android Studio implementation means building Android applications using Android Studio tools, Kotlin Java code, UI layouts, Gradle builds, emulator testing, and deployment tools. Simple flow. Open Android Studio, create project, build UI, write Kotlin Java logic, run app, debug, test, build APK AAB. Example, full stack flow. Android app, Dash, Spring Boot REST API, PostgreSQL database. Why developers learn Android Studio? Developers learn Android Studio to build: check Android mobile apps, check business apps, e-commerce apps, social media apps, travel apps, finance apps, fitness apps, full-stack mobile apps, API-connected mobile apps. Backend developers learn Android Studio because they already understand REST APIs, authentication, JSON, databases, business logic, architecture. Android Studio helps backend developers become full-stack mobile developers. Android Studio architecture overview. Typical Android app architecture: activity, screen, ViewModel, repository, API service, backend, API, database. Full stack example: Android app, Retrofit API client, Spring Boot backend, PostgreSQL, main Android development technologies. Technology purpose: Android Studio, official IDE. Kotlin, recommended modern language. Java, older but still used. Jetpack Compose, modern UI toolkit. XML layouts, traditional UI layout. Gradle, build system. Emulator, virtual. Android device, Logcat logs, debugging Retrofit REST API calls. Room local database, ViewModel UI state management. Jetpack Compose is Android's modern toolkit for building UI, and Android's official beginner course teaches app development using Kotlin and Jetpack Compose. Step 1. Install Android Studio. Install Android Studio from the official Android developer site. Basic setup includes: check Android Studio, check Android SDK, check Android emulator, check Gradle integration, check device manager, check app templates. After installation, open Android Studio. Create project. Install SDK components. Create project. Run emulator. Android's official install guide says Android Studio setup can be completed in a few clicks after checking system requirements and downloading the latest version. Step 2. Create new Android project. In Android Studio, File, New project. Choose template. Empty activity. Recommended for beginners. Language: Kotlin UI, Jetpack Compose, minimum SDK, choose based on target users. Android Studio's project creation guide explains choosing a project type, configuring project settings, and then building, running the app. Step 3. Understand project structure. Typical Android project: My Android app, app/main, Java, res, Android manifest.xml, build Gradle, settings Gradle, important folders, Folder file purpose, MainActivity.kt, main screen code, res resources like strings, images, themes, Android manifest.xml, app configuration, build Gradle, app build configuration settings.gradle, project module settings. Step 4, understand main activity. Main activity is usually the first screen. Jetpack Compose example, package, com example, my app, import Android OS Dumble, import Android X activity, component activity, import Android X activity compose set content, import Android X compose.material3 text, class, main activity, component activity, override, fun on create, saved instance state bundle, super on create, saved instance state, set content, text, hello Android. Simple idea. Main activity starts app UI. Set content displays compose UI. Step 5, run first app. Click run or use shortcut. Shift plus F10. Android Studio will build project, install app on emulator device, launch app. Output. Hello Android. Step 6, create Android emulator. Open. Tools. Device Manager. Create device. Choose. Pixel device. Android system image. API level. Emulator settings. The Android emulator comes with Android Studio and is used by creating an Android virtual device, then running the app on it. Step 7. Understand Gradle. Gradle builds Android apps. Common Gradle tasks. .gradle build, .gradle assemble debug, .gradle test, .gradle connected Android test. Android Studio uses Gradle to compile code, download dependencies, build APK AAB, run tests, manage build variants. Step 8. Add dependency. Dependencies are added in app build Gradle. Example. Dependencies, implementation, Android X.core, core KTX, latest version. For API calls with Retrofit, dependencies, implementation com_up.retrofit2, retrofit 2.11.0. Implementation com_up.retrofit2, converter.gison 2.11.0. Then click Sync Now. Step 9. Jetpack Compose UI. Compose UI is written in Kotlin. Example. @composable, fun, greeting, name string. Text equals hello $name. Use X. Set content. Greeting Android. Simple idea. Composable function equals UI component. Step 10. Compose column layout. @composable fun, login screen. Column, text, login, text, email, text, password. Column means vertical layout. Common Compose layouts. Layout purpose, column, vertical layout, row, horizontal layout, box, overlay layout, lazy column, scrollable list, scaffold, app screen structure. Step 11. Compose button. @composable, fun login button. Button on click, print line, login clicked. Used for login, submit, navigation, save, delete. Step 12. Compose text field, @composable, fun, login form. var email by remember, mutable state of 0. Text field, value equals email. On value change equals email equals it. Label, text, email, important. Remember plus mutable state of stores UI state. Step 13. Build login screen. @composable fun, login screen. var email by remember, mutable state of n. var password by remember, mutable state of n. Column, modifier, equals, modifier.padding 16 dp. Text field, value equals email. On value change equals, email, is it. Label, text, email. Text field, value equals password. On value change equals, password is it. Label equals, text, password. Button, on click equals, println, login clicked. Text, sign in, Step 14. Understand XML layouts. Older Android apps often use XML layouts. Example: text view, Android layout width, wrap content, Android layout height, wrap content, Android text, hello Android, XML layout file, res/layout/activity-main.xml, Java Kotlin activity loads it, set content view, R layout, activity main. Beginner advice: learn Jetpack Compose first for new apps. Understand XML for older projects. Step 15. Activity lifecycle. Activity lifecycle methods. Method meaning: on create, activity created; on start, activity visible; on resume, activity interactive; on pause, activity partially hidden; on stop, activity hidden; on destroy, activity destroyed. Example: override fun and create saved instance state bundle. Super.onCreate saved instance state. Logd MainActivity onCreate called why it matters. Kirk save state handle navigation, manage resources, avoid memory leaks. Step 16. Navigation. Compose navigation uses navigation components. Basic idea: login screen, home screen, profile screen. Routes. Object routes, const val login, const val home equals home, const val profile equals profile. Navigation helps manage multiple screens in one app. Step 17. ViewModel. ViewModel stores UI state and business logic. Example: class login ViewModel, ViewModel, var email by mutable state of private set, var password by mutable state of private set. Fun on email changed, value string, email equals value. Fun on password changed, value string, password equals value. Benefits: separates UI and logic, survives configuration changes, survives easier testing, cleaner screens. Step 18. Repository pattern. Repository handles data operations. Architecture. Screen dash, ViewModel dash, repository dash, API database. Example: class, user repository, private val API service, suspend fun get users, list user, return API service get users. Step 19. Create data model. Example: JSON. ID 1. Name John. Email john@example.com. Kotlin data class. Data class user. Val ID long. Val name string. Val email string. Used for, comma, API response, local data, UI state, DTO mapping. Step 20. REST API integration with Retrofit. Retrofit interface. Interface API service. At get API users, suspend fun get users, at post /API off login, suspend fun login, at body request, login response. Retrofit setup. Val retrofit equals retrofit builder, base URL 10.10.2.2 add converter factory, Gauss converter factory create. Val API service equals retrofit.create API service.class.java. Important emulator note. Android emulator uses 10.0.2.2 to access localhost on your computer. So if Spring Boot runs on your computer, http:10.0.2.2.8080. Step 21. Android plus Spring Boot integration. Typical architecture. Android app, dash, retrofit, Spring Boot REST API, dash, PostgreSQL. Login flow. Android login screen, post/API auth login. Spring Boot validates user, returns JWT token, Android stores token, Android sends token in API headers. Header. Authorization. Bearer token. Step 22. Store token securely. For simple learning. Shared preferences. For production-sensitive tokens. Encrypted shared preferences. Secure storage approach. Avoid. Negative logging tokens. Hard-coding credentials. Storing long-lived secrets carelessly. Committing secrets to Git. Step 23. Add authorization header using OKHTTP interceptor. Vol client equals OKHTTP client builder dot add interceptor chain vol token equals token provider dot get token. Val request equals chain request new builder add header authorization bearer $token build chain dot proceed request build. Use this client in Retrofit. Val retrofit equals retrofit.builder base URL http://10.2.2.8080.client.addConverterFactory.gooseonConverterFactory.create build. Step 24. Debug with Logcat. Logcat shows app logs. Example. Log D, login screen, login button clicked. Log E, API error, login failed. Use Logcat for check API errors, check lifecycle events, check crashes, debug messages, state changes. Important. Do not log passwords, tokens, or sensitive personal data. Step 25. Use Android Studio Debugger. Debugger helps inspect code step by step. Use check breakpoints, check step over, check step into, check variable inspection, check call stack, check evaluate expression. Debug flow. Add breakpoint, run debug, trigger action, execution pauses, inspect variables. Step 26. Common Android Studio errors. Error common cause. Gradle sync failed. Dependency version issue. Emulator not starting. Virtualization device issue. App crashes on launch. Runtime exception. API not working. Wrong base URL. Clear text HTTP. Blocked HTTP instead of HTTPS. Permission denied. Missing runtime permission. Build failed. Syntax config issue. Step 27. Clear text HTTP issue. If calling local HTTP API. http://10.0.2.2.8080. Android may block clear text traffic depending on config. Development only manifest option. Application Android uses clear text traffic. True. Application. Production best practice. Use HTTPS. Step 28. Permissions. Some features need permissions. Call in internet, camera, location, storage, media, Bluetooth. Internet permission. Uses permission, Android name, Android permission, internet. Location example. Uses permission, Android name, Android permission, access find location. Important. Some permissions also need runtime request. Step 29. Testing Android apps. Common test types. Unit tests, UI tests, integration tests, manual device tests. Android's Testing Fundamentals Guide explains that testing apps improves correctness, functional behavior, and usability before release. Unit test example. Class login validator test. At test, fun email should be valid. Val result is valid email test at example.com. Assert true result. Step 30. Build APK, AAB. Debug APK. Build bundles /APKs. Build APKs. Command. Gradle assemble debug. Release bundle. Gradle bundle release. Output. App build outputs APK. App build outputs bundle. For Google Play, use Android App Bundle, AAB. Android Studio Implementation Roadmap, beginner level. Learn. Android Studio UI, project creation, emulator, MainActivity, Kotlin basics, Compose basics, buttons, text fields, layouts, build. Simple login screen, intermediate level. Learn. Class, ViewModel, repository pattern, retrofit, JSON models, navigation, API integration, token handling, error handling. Build. Android app connected to Spring Boot API advanced level. Learn. Room database, offline support, work manager, push notifications, testing, performance profiling, release signing, Play Store deployment, build, production-ready Android app, recommended project structure, app, source, main, Java, COM, example, app, data, API, repository, and model, domain, use case, UI, login, home, profile, navigation, KT, benefits, check, scalable structure, cleaner code, easier testing, better separation of concerns, real-world example, Android travel app, architecture, Android app, Spring Boot API, PostgreSQL, image storage, features, all-in, register, view posts, create travel post, upload image, view profile, search places, comments, Android responsibilities. Check, UI screens, API calls, token storage, navigation, image picker, loading state, error handling, backend responsibilities. Check, authentication, check, authorization, database operations, check, file upload, business logic. Common beginner mistakes. 1. Putting everything in MainActivity. Bad. UI, API calls, validation, token handling, and business logic all inside MainActivity. Better. Screen means ViewModel, means repository, means API service 2. Wrong, localhost URL. Bad. http://8080 from emulator. Better. http 10.0.2.2 3. Ignoring loading state. Bad. User clicks login and nothing happens. Better. Show loading indicator. 4. Logging sensitive data. Bad. Logd, token. Better. Do not log tokens or passwords. 5. Not handling API errors. Always handle. 400 bad request. 401 unauthorized. 403 forbidden. 404 not found. 500 server error. Timeout. 6. Not testing on real device. Emulator is useful, but real device testing catches. Keyboard issues, performance issues, camera issues, notification issues, network behavior. Best practices. Check. Use Kotlin for new Android apps. Learn Jetpack Compose for modern UI. Check. Understand XML for legacy apps. Check. Keep activity small. Check. Use ViewModel. Check. Use repository pattern. Check. Use Retrofit for REST APIs. Check. Handle loading and error states. Check. Use HTTPS in production. Check. Do not hardcode secrets. Check. Do not log sensitive data. Emulator and real device. Check. Use Gradle carefully. Check. Keep dependencies updated. Check. Use meaningful package structure. Check. Write unit tests. Prepare release builds properly. Android Studio interview questions. 1. What is Android Studio? Android Studio is Google's official IDE for Android app development. 2. What is an activity? An activity represents a screen or entry point for user interaction in an Android app. 3. What is Jetpack Compose? Jetpack Compose is Android's modern UI toolkit for building UI with Kotlin. 4. What is Gradle in Android? Gradle is the build system used to compile, package, test, and build Android apps. 5. What is an emulator? An emulator is a virtual Android device used to run and test apps without a physical device. 6. What is ViewModel? ViewModel stores UI-related data and logic and survives configuration changes. 7. What is Retrofit? Retrofit is a popular HTTP client library used to call REST APIs from Android apps. 8. Why use 10.0.2.2? The Android emulator uses 10.0.2.2 to access the host machine's localhost. 9. What is Android manifest.xml? It defines important app configuration, such as activities, permissions, app metadata, and features. 10. What is Logcat? Logcat is Android Studio's tool for viewing logs from apps and the Android system. 30-day learning plan, Week 1, Android Studio Basics. Learn Android Studio installation, create project, emulator, MainActivity, Kotlin basics, Compose basics. Practice. Build Hello Android app. Week 2, UI implementation. Learn. Click, comma, text, button, text field, column, row, lazy column. State management. Practice. Build login and profile screens. Week 3, API integration. Learn. X, retrofit. X, JSON models. X, repository pattern. X, ViewModel. X, loading state. X, error handling. Practice. Connect Android app to Spring Boot API. Week 4, debugging and deployment. Learn. Logcat, debugger, permissions, testing, APK AAB build, release basics. Practice. Build and test complete Android app. Full stack project idea. Project Android plus Spring Boot user management app. Features: login, register, profile, user list, update profile, JWT authentication, API error handling, loading state, architecture, Android Studio app, down, retrofit, Spring Boot REST API, PostgreSQL. Recommended Android structure: UI.login, UI.profile data, API data, repository data, model navigation. Android Studio is the main tool for building Android apps. Important concepts include COGS, Android Studio setup, project structure, MainActivity, Kotlin, Jetpack Compose, XML layouts, Gradle, emulator, ViewModel, repository pattern, retrofit, Spring Boot API integration, Logcat, debugger, testing, APK AAB build. Backend developers already understand. Check APIs, check authentication, check JSON, check databases, check business logic. This makes Android Studio easier to learn as a full-stack mobile skill. Key idea: Android Studio allows developers to build, debug, test, and deploy Android applications that connect to modern backend APIs.